linked lists. This is a linear data structure that holds the elements sequentially. Okay, this actually is you can just imagine this one node as a small structure. Structs that we have studied already. One structure, copy yet another copy. Then you have yet another copy, and in the beginning you have one copy. Okay, these are interconnected in a row or in a sequence, and these elements are called nodes. Okay, it allows the dynamic resizing. For example, I just need to remove this item, this node from here. If I need to remove this one, I would just remove this one and connect the line from here to here. This one would be gone. So this pointer actually would start pointing to this node, and this one would be gone. So it's resizing is the key for efficient memory management. You deallocate and delete the nodes when you need to free the memory. You allocate as much memory as you require in your program, and you do not lose the memory that is unused in your program. Like creating, for example, a student database or employees database, and you create the nodes that have a linkage with each. And another example, the good example would be kind of a folder structure, for example. You said, okay, I am displaying the folder structure and I need to remove certain folder from it. Or maybe the end node, which we usually call tail. This is the last node. You have removed it. So this one becomes the tail node, the last node. This becomes the last node. This one is going to become the last node. If this node is gone, this one becomes the last node. First node is always head. And within the structure, a node within the structure should be pointing to a next node of the same type. Head does not have a parent one. We're going to study doubly linked lists as well. These are singly linked lists. There is single in the sequence, and every structure is connected with the same type of structure next to it. In the end of all the list, the last one is not connected to any next node. I hope it does make sense. The best part of linked list is you can resize it. You can insert nodes here. For example, you have deleted this node. Let's draw here. You deleted this node. Once you have deleted, and then you have created yet another node and inserted it here. Okay? Inserted it here. Let me just... Okay. You insert it here. After deletion, you insert it here. For example, you create yet another node here. And you say, okay, I have a new node. It should be inserted in between these two nodes. So what you do is, this will start to point here, and this will start to point here. And you remove this link. This link is gone. So you have a new node. So insertion as well as deletion allows you to utilize the memory perfectly, and you do not waste the memory, and it's efficient. Errors are much faster because you have index, of course. These are not going to be as efficient as arrays, but with the arrays, even if you use VLAs, you cannot resize the VLA at runtime, of course. You'll have to do a lot of things to do that. But with this technique, you can resize it to any dimension that you need, any size that you need. This is the use of the linked list. We are going to see one example. a quick example. We'll see the deletion as well as we will try understanding the insertion as well.